In today's tutorial we will merge three models: the Grounding DINO, the Segment Anything, and Inpainting. So basically we will take a test image and we can replace the bench with a sofa, with a colorful sofa, using these three models and our own text prompt. All the process would be explained and covered within the code. And this tutorial is part of this playlist. You are most welcome to subscribe for my channel. Let's start with the installation part. So as you can see here under a grounded segment anything, I will leave several files. One would be our test image, so this would be our test image, an instruction file, and 5 Python files that you should run later after the installation part. So let's start with the installation. Basically, it's important to understand that this Python library runs well on Linux environment, and since I have a Windows environment, I'm running the Linux using the WSL. So in order to install WSL, I will leave here a link how to install it. Of course, you can go to this website. I will leave a link in the instruction file. If you have a Linux environment, you should go to this environment and we should start. I will run a PowerShell. It's better to run it as administrator, so I will run it as administrator. And let's go here and let's shrink it a little bit. One more second. Great. So we have here a Linux environment and here are all the commands. So let's run WSL. Great. So now we are using our Linux environment. You can see here the path in my local machine, and here you can see that I'm using Anaconda in this Linux environment, and now I'm on the base environment. Basically we will going to create a new environment. So let's clear everything and we can start. First of all, we should have to set up the CUDA variable. So let's copy this command. And as says here, it prints nothing. That means that that we didn't set here our CUDA path. So let's add this command. And now we now we have a reference to our CUDA environment. Now we have to choose a path for the installation. I prefer to install it on my Python cool stuff. So let's go to my environment. As I said, it's Python cool stuff. So as you can see here, we will put it under Mount C Python cool stuff. So now we have to clone the grounded segment anything. So we should copy this command, git clone, and the path to our GitHub repository. Let's wait a few more seconds so it downloads all the relevant files in this repository. Great. Now let's go inside this folder, cd gr grounded segment anything. Great. So as you can see, now we have all the files that download using the git clone command. Now we have to create a new Conda environment. Let's copy the command here. But since I already created an environment named GSA4, let's create a Conda environment named GSA5 and as you can see it will be based on Python 3.12. Great, now let's activate it. Conda activate GSA 5. So as you can see here, our current environment was changed and now we are working on GSA 5. Let's continue. The next step is installation. As you can see here, we have three types of installation. One is the requirement.txt, that means all the relevant Python libraries, and also we have to install two more Python that are not part of the requirements. So let's copy the first one and let's run it. So this installation was finished. Let's continue with the next installation of IPython. I believe it will be quicker. Great. And the last one, supervision, and it should be this specific version. Okay, let's continue to the next step. The next step, we have to go to the GroundDINO subfolder. Okay, so let's ls cd GroundDINO. Here it is. This is the folder. So cd GroundDINO, and inside this folder we have to run this command: pip install -q and dot. And let's click enter. Okay, we finished that part, and now let's go back, and now we have to go inside the segment anything subfolder, and once again run the pip install -q. So cd, and next is segment anything, and once again pip install -q. Okay, we finished this as well. Great. Next we have to download the Feit sum model from this URL. So as you can see, you can copy and paste it and download that file. I already download the file, so if we go back here and go back to the main folder and write ls, I already downloaded it, so we have to find it here. It should be here. Here it is, this one. So this is the weights for the segment anything model. Next, now we have to run the VS Code. So in order to do that, we first need to install the VS Code, and here is the link how to install it. Go back to the Python cool stuff, and the command should be code. You have to write code and it will run the VS Code from this folder. So let's run it. As you can see, it's download and install it on the same time. And as you can see, we have the VS Code here. So now when you run the code command, it runs it from the Linux environment. So let's open the folder and let's go back here, and have to go to the mount mnt and then C, and then C, and now we are looking for the Python cool stuff, and let's click OK. Yes, I trust. And this is our working folder, ground segment anything. And now let's copy all the relevant the relevant files to run it here on this environment. So if you go to the link in the video description and download all the file, you will get this bunch of files. One is the instructions, this is our test image, this is the one, this cute teddy bear, and also we have 5 Python files. So let's copy all these files to my working directory. So my working directory is under C and Python cool files, and here let's copy it to here. So now we are expecting to find all the files here. This is the instruction file, and these are all the Python files that we will run one after each other. Before we start running the code, we have to change our current working environment. In the VS Code, then we should click the Control Shift and P, Control Shift P, and then select Interpreter, and the name of our environment is GSA5. We have to choose it, and now we are ready to run all the files. So we are going to cover all these 5 Python programs. We will explain the code and run step by step each one of those tutorials. So let's start with the first Python code. Let's name it load model and test image. Basically, it's introduction for the whole process. This code aims to load and utilize several AI models for image processing tasks, including object detection, segmentation, and inpainting. It also integrates 3 main models: Grounding DINO for object detection, Segment Anything for segmentation, and Stable Diffusion for inpainting. So the main target is to enable and building a pipeline that can detect objects in an image, segment them, and then modify the image using the inpainting techniques. So let's cover the code. We are starting first of all with the importing the libraries, as you can see here, and then we divided to several processes. First of all, the grounding DINO setup. So the code appends the grounding DINO path to the system path to enable importing modules from the GroundingDINO directory. So this is this part. And also we have a similar part for the segment anything. If you look at the main folder, you will find a GroundingDINO subfolder and another subfolder named segment anything. So both folders was generated during the installation. Then we have a diffuser, this process, and the Stable Diffusion model for inpainting is loaded using the Stable Diffusion pipeline. Okay, this is the command for that. So let's continue to the next step. Then we are defining the device. If you have a GPU card, you should put the CUDA value in the device, and if not, you should use the CPU value. And now we are defining a new function for the process of the GroundingDINO model. This function downloads and loads the GroundingDINO model from Hugging Face Model Hub, and it uses the configuration file to build the model and load the model weights from the checkpoints. And the function returns the loaded model for further use. The next step is loading the model. the grounding DINO is loaded using the load underscore model underscore HF function with specific repository ID, the file name, and the configuration file. The same is the segment anything model is initialized with the specific checkpoint. This is the one that we have downloaded during the installation process. Next, we are defining the SAM predictor. It's part of the initialization process for the segment anything process. So after loading all the models, those 3 models, we should load an image, a specific image that we will play and try all these 3 models over this image. So this is the path for the image, and here we are loading the image, and after that we display the image using the OpenCV library. So this is the first process. Let's run it and see the result. And here is our test image. So the last part of the code is loading and displaying this image. Let's continue to step number 2. And the step number 2 is dealing with object detection. So all the process is, as I mentioned earlier, is based on 3 models. The Grounding DINO for the object detection, the segment anything is for the segmentation process, and the Stable Diffusion for the Inpainting. So taking out something and replace it in our image. So all the process, if I start with the beginning, is basically the same as step number 1. The major change, as I said before, is this process of the object detection using the Grounding DINO. So I created here a function called detect, and let's focus on this function. This function detects objects in an image using the Grounding DINO based on a provided text prompt, like a person, or in our case would be a teddy bear. It performs the following steps. It uses the Grounding DINO model to predict bounding box around objects that match the text prompt, and it converts the bounding box format, the center X, center Y, width and height, to an X-min, Y-min, X-max, and Y-max. You can see the process here. In this process, we are running in a loop through all the detected boxes, and we convert all the data. And after that, it scales the bounding box to match the actual image dimensions. And the last process, using the OpenCV rectangle function, it draws a rectangles around the detected objects on the original image using OpenCV. And as you can see here in this function, we are in this command, we are running our detect function and sending several arguments like the image source, the image, and very important, the text prompt, in our case a teddy bear. And after that, we are displaying both images, the original image and the object detection image. So let's run it and see the result. So let's see the result. Here is the result. As you can see, this is the original image, and this is our next image, the step number 2 image after the object detection process. So now we are in step number 3, and step number 3 is dealing with the segmentation. So basically, what is the segmentation and the inpainting process? We are focusing on an object, and then we would like to segment this object, not only as a box around the object, but all the area in the image that contain this specific object, and in the next phase we would like to replace it with something else. If we go back to our image, we in the previous Python code we was focusing on the object, but let's leave the object and now let's focus on the bench. We would like to replace the bench. So let's go back to our code, and now let's look for running the detection, the detect function. But please watch that I replaced the previous text from a teddy bear to a bench. So now we will look for the bench object in the image. And the next change is adding this function which do the segmentation process. As you can see, this function collects 3 arguments: our image, the same model, which is the instance that we created in step number 1, and the boxes. The boxes are the detected objects from step number 2. So inside the boxes we will have the points for our bench. And after that we are using this function that named draw mask that draw the mask, draw an image that contain only the mask. And we have now in this process we are running the segment function, and in this command we are drawing the mask. So let's run it and see the result. Great. So this is our original image. This is the object detection, and now as you can see we are focusing on the branch, and this is the segmentation process. As you can see we are segmenting the branch, and here we are drawing the mask. This is the mask of the bench, and this is the inverted mask. So here we are focusing on the mask, and all the rest is the image was replaced as a black background, and here is the same but is inverted. So now on the final part, which is generating a new image. Once again, it's based on our previous code, but the major change now is the significant change is that this version is an addition of Stable Diffusion Inpainting functionality. So it includes a section for generating a new image using the Inpainting capabilities, and this is of course based on Stable Diffusion, and it will generate a new image while we are replacing the bench with our own prompt, our text prompt, and we will see the result that is a combination of the original image and our prompt. It's basically very, very nice. Let's go for the specific section that was added to this Python code. So as you can see, we add a section started with generating a new image, and this is the function for the process, and the function gets several arguments like the image, the mask that was generated earlier, a prompt, we will speak about the prompt, a negative prompt, and also our pipe and choosing a seed if you would like to get the same result each time we run this code. And inside we are getting our image, resize it to our model dimensions, and creating a generator, and then using the pipe to get the result. And the result will be based on this prompt. Our prompt will be a sofa, high quality, detailed, cyberpunk, futuristic. So what we are going to do is replace the bench with a sofa, and this will be our negative prompt. It's for this process it will be none. As you can see, you can test it with another negative prompt like low resolution and ugly. I chose a seed 33 just to get the same result each time. and then we are converting the results back to an image and generating a new image based on all these arguments. So what we are expecting to see, we're expecting to see the previous results, so the original image, the detected bench, and also the mask and the inverted mask. And then we would like to see another image, which is the generated image. I believe that if we will run it, the result will be more clear. So this is the same as our previous result. As you can see, this is our original image, this is the detection, so the same process. And let's close this image and let's see the final result. As you can see, it's the same image, but we replaced the bench with a sofa, futuristic, and all the other nicely words that we add to our text prompt. Thank you very much. I hope you enjoy this session as well, and you are welcome to subscribe my channel. More videos will be uploaded soon. Bye bye.